So today we are going to cover VCarve Pro and how to generate toolpaths for the Recontech Exitech 1312 machine. So normally the software is available on this computer, but so I'll make it also so that the software you can use on other computers. So for the precision milling machines, the software is also on these mini computers. And yeah, so you can find it on the desktop usually. So it doesn't matter whether you log in with the admin account or the user account. It's always here, and it starts with this interface. And the first thing that you need to do is to create a new file. So sometimes you might start to look for different kinds of options and the things that you remember that are possible with VCarve but are not possible to do. Mainly, you won't be able to find those because you haven't created a file yet. So you create a new file, and before you do that, you should at least approximately know your material. So you should know how big your cutting area is going to be. So let's go with 900 by 900. And you need to know also the thickness of your material. So 12 millimeter plywood, or could it be like 20 millimeter MDF, let's say. Then, so you need to know where are you going to set your Z-axis, Z0 position. So remember we used this calibration tool. Sometimes it might be necessary to set the Z-axis on the surface, so where you're putting, so on the sacrificing layer, and that you should know. So whether you are using the material surface or the sacrificing layer, and this you should set here because it's important whether the Z is under here or the Z is on top of the material. Then it's important for the toolpath generation. So it's going to generate relative values to that offset value. And then XY datum, it's like this origin point along XY axis. And as you remember, so we usually set it to this left closer corner. And then you hit OK. And now it's kind of Illustrator, but a bit more technical Illustrator. So it's more like a CAD drawing program. You can use it to draw all kinds of shapes. So if you don't have your design ready and you need to quickly CNC mill something, like a polygon, let's say. So you can specify a number of sides. So let's say 7. You can specify a center point. You can specify a radius, 25 millimeters, 2.5 centimeters. It's going to be a shape big like this. So yeah, let's hit create. So it creates a thing over here. And we could create a bigger one around it. Yeah, so I'm going to add another one, which is slightly bigger. Let's say 50 millimeters in radius. Yeah, after using this tool, we can hit close, and we can go to one of the editing tools. Like let's select this transform move tool. Select the shapes. We can move them around and place them wherever we want, and you know, also scale them if necessary. Do all kinds of things. And when you're importing things into this software, it's important to make sure that all of these points are connected. And in order to do so, you would go to Edit, Join Vectors, or just hit letter J on the keyboard. Yeah, it's going to ask you for the tolerance. This is fine. It's also going to show you how many are open and how many are closed. All right, let's go with fillets, for example. So you can create fillets. It's a really nice drawing tool. I really, every time I use it, I start to like it more and more. And you can also, specify the fillet radius. So, 10 millimeters over here. T-bone fillets. I didn't know that you can actually do those. So that's, for example, if we create a square like this. Right. Yeah, so I created it multiple times, so it's time for another function, for example. So if you don't know, so another thing, if you kind of know that there might be overlapping objects. So in this case, you see there are overlapping squares, and sometimes you don't see them, but you're not sure whether they are there or not. So you can select all and go to Edit and Selection and select all duplicate vectors. So it's gonna select all the vectors that are duplicated, which have the same values, and in this case there are. So you can see that underneath there's one selection. You can hit, maybe not delete, yeah, you can hit delete. And now when you're going to try to move this, yeah, it's just going to be one layer, so it's fine. So it removed all the duplicates. So these two main functions are remove duplicates and edit join vectors. So if there's an open vector somewhere, then it can join those without. Let's try to just close, draw a line and not close it completely. So I'm just gonna try to move this as close as possible, but not click on the point here, but leave it a little bit open, like so. And now when I will go to edit join vectors, it will still shows me as closed. Oh no, there's a selected vectors, closed 0, open 1, yeah, and then join, and now it joined. And now if we zoom in, you'll see it's joined. So yeah, so these are examples. I'm just gonna create something really clean here, like maybe the same. So, and maybe I'll scale it a little bit, just like that. Here, and let's try. Yeah, I got really curious about this fillet. So T-bone fillet. So you can tool. So for example, if you need to create these T-bones, so in order to fit things together, then you need to know the radius of the tool. So let's say we use an 8mm tool, and it's going to create. Yeah, so there's like T-bone fillet, but we could also go with a dog bone fillet. So it's going to optimize it like so. This is much nicer because it kind of chips away less material, and it looks less ugly, especially if you're cutting with a smaller tool. Close. And yeah, so let's say that this is going to be our pocket, and then let's create something that fits, that might fit in. First, let's measure this. So where's our measurement tool? And yeah, first point here, second point, y distance 63.198 millimeters. So let's remember this value, like 63 millimeters. So let's make a square that is 63 millimeters. Create, close. Let's move it around. Let's just try. Yeah, it kind of should fit in. So we cut it. Yeah, it's gonna be funny. So we're gonna cut this square out, and it's gonna be a simple design. We are going to try to put this square into this pocket. How exciting. Yeah, okay. And now, in order to generate toolpaths, we need to open the toolpath panel over here. So let's snap it to the edge of the window. And let's start with the profile toolpath, or how to cut out a contour, so a piece of it. And so we want to cut out this square. And for this we don't need the T-bones because the tool is nicely going to go around and it's going to leave these sharp edges, so it's fine. So since we specified the material to be 20, actually we should maybe change it to something else. So we need to specify the cut depth. So let's specify 20.2. Yeah, and then for the tool, we need to select the tool. Since we specified the dog bones to be 8 millimeters, so we can just select the tool that is also 8 millimeters. So end mill 8 millimeters. Here, and the important thing here is to double check the feed rate values. So remember the feed rate calculation. So can you tell me the formula that has to that we used the other time? Do you remember that? So okay, once more. So here we have our tool, all right? So usually it has a number of flutes. So this tool has 2 flutes. So you can also double check that by looking at it from the top. So you see it has 2 cutters here, straight line, and on each side there's 1 cutter. It means it has 2 flutes. So tool, it has a diameter also. So we need the number of flutes, the diameter, and from the diameter we can tell the chip load. So we need to know the chip load for this diameter of tool. And for each material, the chip load is going to be a bit different. And chip load means like how much material each of these blades are going to be able to cut off in one rotation. It's going to kind of chip off a little bit of material, and then it's going to move forward and cut another bit of material, move forward, cut another bit. So the chip load is how much it cuts per revolution. And for that we have this green book somewhere. So this table. You have this, but there's also a website. I need to kind of put it somewhere so you can see. So it comes from CNCRoutershop.com. So and there's a section that tells calculate feeds, and it has this table. And so we have an 8 millimeter tool, which is so it doesn't have specifically an 8 millimeter tool, but we just could look at a 10 millimeter tool and calculate the medium between the 6 millimeter tool. And we are going to cut like MDF. Yeah, we are going to cut MDF. So let's take a look. So for MDF, 0.5 or let's say 0.45 should be good. So that's going to be the chip load, so 0.45. 2 flutes, 0.45 chip load. And the third parameter that we need to know is the spindle speed, so how fast it's going to turn. And for this machine, the maximum speed is 18,000, but we usually go with something like 16,000. So this is also preset here. And in calculator, you enter the number of flutes, then times the chip load, which is going to 0.45. Not 45, but 0.45. And times the spindle speed, 16,000. And we are going to get feed rate. It's quite big, actually. I'll just check once more. Should be all right, 0.45. Once more, 2 times 0.45 times 16,000. Yeah, 14,400. Plunge rate 1,000 is fine. So this is how fast it's going to move downwards. Tool number not important at this point. So here we can specify specifically like the pass depth. So for 8 millimeter tool, it should be half or a bit less than half of the diameter. Step over, so yeah, 40% is fine. So this is how much it's gonna step the other side. So you could also go with 50%, and I'll hit OK. And once the tool is selected, we can also see the number of passes it's going to make. You can adjust those also specifically. So if you look from the top of the material, these are going to be the consecutive passes of the tool that it's going to make. And this is not so important unless you want to make a really clean finish. And tabs. You probably remember tabs, so these are important. So you can add them by distance, constant number, like this, or you can place them manually, like this. And this is also not so important at this point. And now you can hit on calculate, and it's gonna tell you that, hey, the depth of the cut is actually more than the actual material. And are you aware of the fact that the cutter is going to cut through the material, which is fine with us because we are going to cut on top of the sacrificing layer. So it's going to cut into the sacrificing layer a little bit. To hit OK. And here you can see a simulation of what is going to be cut, and you can play, and this is going to be the result of the cut. Looks fine. So you can see that it has these sharp corners for the part that we want to use. I'm going to hit close here, and I'm going to go back to the 2D view. And for this, we want to create a pocket. Here on the toolpath menu, so first we select the actual vectors that we want to use for pocketing, and we need to select the second one, pocket toolpath. And for that, we also can specify the depth of cut. So maybe you are not going to cut the full way, so we are just going to cut it halfway in. And yeah, let's say that we want to cut 10 millimeters. And for the end mill, we are going to use the same 8 millimeters end mill. Okay, so we don't have to change the settings this time because they are already preset from the previous time. It's going to be only 3 passes. Here we can specify some ways how it's going to be cut. So raster is fine. And everything else is not that important. So we hit calculate. Now, yeah, this is going to be a pocket. So you're going to cut out this and put it in the pocket. So another thing that we would like to do is going to cut out this as a little example board. So we could go to the 2D view again, and we could draw a rectangle. And can I just draw a free rectangle? Like so, yeah. It's going to give me this radius around here. Let's see what is going to happen if I'm going to transform it. Is it go? Yeah, it's scaling the corners as well, which I don't like. So we go once more to the square. And you click and drag. So close. So now you can adjust it a little bit. Or actually it's just going to be this one, because we are going to cut out this. And, And we could create a few fillets also here. Normal fillets, 8 millimeters, like so. And let's create another profile toolpath with this in mind. 8 millimeter tool, alright, 20.2. And for this we are also going to add tabs. Just add one here, 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 and here. Oh, what happened? So yeah, if you left or right click, then it's going to remove all the tabs apparently. So
why this on a different one?
Oh yeah, it actually didn't. I think the Control Z move was somehow. Okay, so I'm going to Profile Toolpath again. I'm selecting the profile. The tool is already selected. The depth is going to be cutting through the whole material, and I want to cut outside. So from outside, not the inside. You could also specify it on the line if sometimes needed. Then I'm going to add tabs. So tabs are already added, and profile 2. So
what's the whole difference between these three?
Yeah, so I'll show you. So outside, so now if I hit calculate and hit OK, it's going to cut it along the outer side of the line. So you see it leaves these nice 8 millimeter fillets over here. Here's a nice feature that you can go one step back, double click on it, it's going to open it up. And then you can specify it also on the inside. Hit calculate. Okay. And here you see it's calculating on the inside, and now it's going to remove the inside of the material and leave this as a square. But we want to have it outside.
So when you created this pass, it was on, or I forgot.
It was on the outside, so I'll show you. You can reset the preview, and then you can cut. So now it's going to be like this. And on the line, it's going to be along this edge here. Now that we have these three toolpaths, we can actually, since they are using the same tool, we can export them as one file. We need to go to the Save Toolpath menu by clicking on this icon here. And here's this checkbox that output all visible toolpaths to one file. And in order to make them visible, I need to select these check marks over here. And it's going to tell you which toolpaths are to be saved over here. So if you have a VCarve version which has many options over here, you have to select the Mac 2 or Mac 3 ARCS millimeter format, which is going to export it as in a text file. And then you click on Output Toolpaths, and you go to Desktop. I'm going to go to My Folder and create a new folder with VCarve demo. And so which means pocketing and cutting, 8 millimeter, like 8 millimeter tool, 20.2 millimeter depth, like so. And I will hit save. Maybe because it was a, so you shouldn't check the output directly to machine. Save toolpath, this, save, yes. Now we can check the file, demo, and you can open it in Notepad++ here.
Sorry, can I just snap it off?
Yeah, just wait a tiny bit that it's gonna hand it over to you like on a plate like this. So it's just good. It's cooling down the build plate a little bit. It's gonna be also easier to remove. Yeah, and this is G code again. So it's the same. So for the 3D printers, we were looking at the G code, and now for the CNC machine, it's basically the same thing. But of course, like it's interpreting it in different way. The motors. Yeah, and the next thing is to set up the machine and actually cut it. Yeah, so for the recording, I just wanted to show the VCarve part, and then for the cutting, that's covered in the other video where we set up the machine for Fusion 360, and then from there, there's the part where you operate the Mac 3 software, which is this one. I'm going to open it up just for the reference so you remember which one was it. So now the machine is not on. This is why there was the error message. This is the software that we would use. We would load the G code with this button and then we would run it. Yeah, okay. Thanks for watching.